What's going on, guys? So today I'm going to show you how to create a database schema. This is for our Music Talk app. It's like Facebook, but people talk about music. It's pretty much the best idea ever. In the previous video, which you don't need for this video by the way, we set up a React and Node front end and back end. We got those talking to each other, and now we can connect to a database to store our data. But before we do that, we need to think about the database schema. What entities or database tables we'll have, and what attributes or database columns each one of those tables should have. So at a high level, let's see, we'll have users, posts, comments, friends, and likes. Users would have a username and a password. Posts would have the post itself, an author of the post, and a timestamp so that we can list them in chronological order, showing the most recent first. For the comments, we'd have the comment itself, an author of the comment, and a timestamp, same reason. Friends, it'd have a user who has the friends and then the friends themselves. And lastly, likes, these would have a user, that's so we know who likes a post, and then a liked post, the post that the user liked. So with that information, we can create a table diagram, a representation of the different tables in the database. Each of those entities can be their own table. Now for users, we mentioned a username and password. We'll also want a unique user ID. It'll be much easier to look up the user by their ID rather than their much larger username or password. This will also act as the primary key for the users table. A primary key is the unique identifier of a database row or entry, and every table must have a primary key. In table diagrams, the primary key is often identified by a filled circle. And we'll also make columns in the users table for username and password. For posts, same thing. We'll want a unique ID, which will be the primary key. But now for the post author, this will be a foreign key. A foreign key is a key that's from a different country than the primary key. Just kidding. A foreign key is a key that references the primary key of a different table. So post author will reference the user ID, the primary key of the users table. So instead of post author being the full username of the user, it can just be the unique ID of that user. This will help when reading and retrieving data, also when joining tables, something we'll get into later. Foreign keys are typically represented by an unfilled circle. We'll make the connection between the primary and foreign key when we create the actual data schema here in a second. So we'll also add the post and created at columns. For the comments table, we'll have the comment ID primary key. We'll have the comment author, which is also a foreign key pointing to the user ID, and post, which will also be a foreign key. A table can have multiple foreign keys. This one will point to the post ID primary key of the post table. That's how we'll link the comment to the correct post. We'll do a created at timestamp so that we can put those in order. And last, but certainly not least, the comment itself. Now the friends table, a little something different on this one. We'll start with the usual friend ID, primary key. We'll do a user foreign key that points to the user who the friends belong to. And now the friends themselves, this one was interesting because those are also users. Well, we can make that a foreign key that also points to the user ID of the user table. So we can have two columns that point to the same primary key. Last table now, the likes table. This one was harder to think about than I expected. I mean, what is a like really? How do you identify it, save it, retrieve it, and use it? Should it be an attribute of the post? So it can be set up very similarly to the friends table. A like ID, which is a primary key, a liked post, which points to the post that's liked, and the user ID pointing to, well, the user ID. We called this user ID instead of user because we can't have two foreign keys with the same name. Note user being used in the friends table. Now we can actually make the likes table a little more simple. We can remove the liked ID primary key and make both the liked post and the user ID collectively the primary key. This is called a compound key. A compound key is when you use two or more foreign keys and use those together to form a unique primary key. Now that we have a clear understanding of the tables we need and the different attributes or columns for each, we can now create our database. For our database, we'll use MySQL. It's one of the most widely used databases out there, so it's very good to learn. It's also extremely reliable. We'll create and configure our MySQL database by using MySQL Workbench. Workbench is a GUI or a GUI or a graphical user interface that lets us architect databases, easily create relations to data and view those relations, add constraints and rules to data, all incredibly easier due to the easy-to-use interface. In previous videos, we downloaded and installed MySQL and MySQL Workbench. You can reference those videos if you still need to download those. I'll toss a couple links in the description. So when you open Workbench here, you'll see your MySQL connections. You'll see the local instance, which will be the MySQL on your machine. In a future video, after we build out and deploy this app, we'll also have a production database connection. You can click into the local instance. It'll have you enter in the password. This is the password that you created when you downloaded MySQL. That password is for the root user. And if you're not seeing this screen, you can click on schemas here. These will be your different databases. You can right click here and click create schema, or this icon here to create a new schema. The different schemas are essentially different databases. So we'll call this one Music Talk. And then you click apply. And it'll generate a MySQL script. Hit apply again. And the SQL script was successfully applied to the database. So we can X out of that. And we see our Music Talk database here. We have the different tables, and there are none now. So we can right click and then create table. And then give it a table name. The first table we'll create is the users table. So we'll call it users. And then click to edit here for this column. We'll say user ID. And then I just hit enter. So it already assigned this PK here is primary key, and then the two ends is not null. And then I usually click auto increment. That's what this AI is. So the first user will have a primary key, a unique ID of 1. The second user would have an ID of 2, and so on. And this is the power of Workbench. We don't have to manually write SQL statements to set these correctly. It'll just generate an SQL statement when we hit apply, which we'll do here in a minute. So let's see, there was the username, so we'll create a column for username. And we see the data type is varchar. So varchar is a data type that lets you save text, or more specifically characters, at a variable amount of characters up to the amount that you specify. So here they defaulted to 45 characters max, and for a username, that seems fine. I'll do not null, and then we will also create the column for password. For this entry, we'll do varchar again, but we're going to set it much bigger, like as big as 1500. The reason for this is it's bad practice to save a password as is in a database. It's better to hash the string or encrypt it before storing it in the database. So a small password like password1234, that's not my password for anything, I'm just saying, could end up being like exclamation point, number sign, AC249T, and so on for very many characters. I'll show you in a future video how to encrypt a password and then decrypt it properly to check it when authorizing a user who's signing in. So we'll hit not null for this as well. And then we can hit apply. You see it generates this SQL statement. So we have the create table, music talk users. So it's the users table inside music talk with these different constraints and the primary key, and then you hit apply, and the SQL script was successfully applied to the database. Close that, and now we can create our other table. And this time we'll do our posts table, so we'll call it posts. Give it a post ID. Make sure auto increment is selected. And now we'll do our post author foreign key. So we have post author. And so this will be an integer because we're going to point it to the user ID primary key. So we'll set that to int and not null. So we make sure there's always a value there. And then to set it as a foreign key and point it to the user table correctly, you can click down to foreign keys here. Foreign key, click edit, and then we call that post author. And then the reference table that we'll be pointing to is the users table. And so the column in our current database for the foreign key is post author, and the reference column is user ID. There's these cool on delete, you can do cascade so that when they delete an entry, it'll also delete all of the child records. So if you want everything gone for that user because you won't need it any longer, that can be great. This can also be dangerous though, because you'll delete all of the child elements. And so for this app, I'm okay with still showing the user's posts after the user has been deleted. There might be other users that are engaging on that post, and I don't want the post to just disappear. So we'll leave it to no action, and we'll go back to our columns here. And we see this is red, that means it's a foreign key. So that's looking good. Start our next column here. And now we'll add a column for the post itself. We'll call that post. This is one I had to put some consideration into. Like, how big do we want the post to be? There are also different text options besides varchar, and like which one is the best to use and why. I'll give you a quick rundown of my research so you can take in a couple factors for your database needs. So storing text or character data types. We have a data type of char, not the varchar, and that has a fixed length. Definitely very useful and can be quick to store and retrieve, but you have to enforce it to be a fixed length. So not a ton of use cases for that, but something to keep in mind. There's varchar, which is a variable length string. It's not quite as fast to store and retrieve, but it doesn't take up unused storage space. And when we talk about speed or performance, this is only relevant with a lot of data, like a lot of data. But if there's potential for that, it's best to set it up early. Varchar used to have a max length of 255 characters, but versions nowadays allow for 65,000 characters to be stored. Since we're talking about databases, I guess that should be technical. It's 65,535 characters. But anyways, there's also a text data type, which is a blob of text and requires more storage space and computing power. Text is harder to index and is actually not stored on the table itself. It's stored on the machine with the table entry being a reference to it. So that's why retrieving and storing takes up more computing power. So we'll stick with varchar. Now all that's left is to determine the max character length. By the way, spaces also count as characters. To determine the max length, I like to use this blind text generator website. Let me bring this in screen here. So you can do lorem ipsum by character amount instead of just the amount of words. So we have characters here. You can increase the number and get a feel for how many words or characters that this is. And so we're looking for like a post length, a max post length. We'll go, that looks good. 4,200 characters. So var char, and we'll change that to 4,200. Kind of random number, but whatever. And not null. And then lastly, there was a column for created at. So we'll say created at, and then this data type. By the way, you have this drop down here so you can kind of see all the different data types that you can choose from. And for created at, we'll do date time, so it'll show the date and time. And we'll set a default, which will be current timestamp. And now that this table is set up, we can hit apply. And then hit apply again. And that was ran successfully. We'll create another table. This will be the comments table. We'll call it comments. And then we'll have that comment ID. Auto increment the primary key. Then we'll have the comment author, which will be an integer because we're going to point to the user ID. Make sure that's not null as well. Go over to foreign keys. That foreign key is comment author. We will reference the users table. So author will be a user. Now this comment author column will be referencing the user ID. I always want to hit apply there, but we can just go back to columns. So we're still in the same table. Now another foreign key here. We'll do post. This will be the post that the comment belongs to, which will be an int, not null. Go to foreign keys, and we called that post. I always leave caps lock on. And so this will reference the post table. And now we can click post, and that'll be pointing to the post ID. We will do created at. It'll be date time with the default of current timestamp. And lastly, but not least, leaving caps lock on again as always, the comment itself. And I guess we'll leave the max length for this one the same as a post. We'll let them leave a long comment. Make sure not null is applied to both of these. And this table looks good. So run apply here. Also, we didn't have to write all this. Beautiful. Moving right along here, let's do the friends table. Create table, call that friends. We'll say friend ID. So click right on auto increment. And we'll have user. This will be an int, not null, foreign key user. Oh my god. Look, I'm recording, so I'm gonna make mistakes. And then the column user pointing to the user ID. And then lastly, the friend, which will also be an int, not null, and will also be a foreign key pointing to the user. So we call that friend pointing to users, and the friend will reference the user ID. Hit apply and apply. Awesome. And then last one, create table. This will be the likes table. Call it likes. And now we're not doing the like ID. We're just going to do the liked post. And the user ID, which will be init. I want this to also be a primary key, and we'll make those foreign keys as well. So we had liked post, and we had user ID. Liked post will be pointing to the post table. User ID will be pointing to the users table. Liked post is pointing to not the user ID. See, it's grabbing columns from the user table. So that's user ID, that's right. Okay, so you're gonna leave that selected. So liked post is pointing to post ID. If we go to columns, we see the primary keys. See the foreign keys are getting set, looking good. Awesome. So one more thing I want to show you is if you go to the home page and you go to models here, click this right arrow, you can see an EER model from database. EER stands for Extended Entity Relationship Model. So we'll create one from our database. It'll connect to our local MySQL, click continue. You'll have to enter your password to the root user again. Hit continue. And then you can choose your database and continue again, and one more time, and one more time. Execute here, and continue again. Oh my god, close. And then here you get this cool kind of representation of your data. Put the users here, kind of separate these out a bit so you can see. Kind of click them all, and yeah. But yeah, as you click on them, you'll see what goes to what. You can, like there we see the post ID is tied to the liked post. Post ID goes to the comments here. So this can be useful too as you're kind of getting a feel for your data and the relationship between that data. Okay, so a lot in that video, but I think it's all good stuff to know and to consider. Hope that helps some people out. If you're creating a database for something else, let us know in the comments. That'd be interesting to hear what people are making. Of course, feel free to like and or subscribe. And if you're still watching, I truly appreciate it. I will catch you in the next one.
Check it.